Hi guys, so today we're going to look at our last thing for polynomials, and that is writing equations. So today is another day that's going to be pretty heavy on the algebra, but it's nothing too terrible that you haven't seen so far. So just to review, a couple things that we looked at in previous classes. One of those was that fundamental theorem of algebra, which basically told us that the degree of the polynomial was how many zeros we had, as long as we include complex numbers and multiplicities. Remember, the multiplicity of a factor is its exponent. So if you have x minus 3 to the 5th power, we would really count that as 5 zeros within that polynomial. Now, it only crosses the x-axis in that one spot, but it would be 5 in our total if we're trying to get to the total degree. Now, another thing that you may have noticed this year, but we haven't really explicitly said it yet, is that imaginary zeros and irrational zeros come in pairs. And that uses something, these two theorems are listed down here at the bottom if you want to see the technical terminology for it. But basically, what that means, if you've noticed, every time we took a square root, we always put plus or minus, because it's always plus or minus. It's plus or minus the square root of 3. Well, that means all of our irrational zeros. So, for example, 1 plus the square root of 7. If 1 plus the square root of 7 is a 0, so is 1 minus the square root of 7. If 1 minus the square root of 17 is a 0, then 1 plus the square root of 17 will also be a 0. So any of those irrational zeros are going to come in pairs. That's also true for complex numbers. So any of our values that have i's, any of our imaginary solutions. So if 3 minus 2i is a 0, then so is 3 plus 2i. If 5 plus 7i is a 0, then so is 5 minus 7i. So all of your complex and irrational zeros are going to have a pair that comes with them. So what we're going to do is we're going to write the equation of a polynomial. So we're going to write this. It says with a leading coefficient of 1, so we're not going to have to worry about finding that a value, but we do need to write it in standard form. And I realize it doesn't say that in the directions, but it should. So we're going to write this in standard form. So in order to get it in standard form, we're going to start with our factored form. If 3 is a 0, then x minus 3 is a factor. Now this tells us the multiplicity is 2, which means that factor is squared. It also tells us the square root of 7 is a 0. Well, if the square root of 7 is 0, so is the negative square root of 7. So what we could do here, one of our factors would be x minus the square root of 7, and one of those factors would be x plus the square root of 7. So in order to get this in standard form, we're going to go ahead and actually do the math and FOIL this whole thing out. So we're going to start with x minus 3 squared. Remember, when you square a binomial, there is a middle term. You do not square the individual terms. X minus 3 squared is x minus 3 times x minus 3. The other thing we talked about is the square double square. So we square, we double, and we square. So that is the trinomial that results from x minus 3 squared. Moving on to the next one, we need to FOIL this out. Well, the nice thing about this looks like a difference of squares. So let's go ahead and FOIL. So x times x is x squared. X times the square root of 7 is the square root of 7 times x. Then minus the square root of 7 times x. And then the square root of 7 times the square root of 7 is just 7. And a square root times itself is just that number inside. I said it looks like a different squares because if we take out those middle terms now, I've got a positive square root of 7x and a negative square root of 7x. Well, those cancel out. So all I have left for that factor is x squared minus 7. Then at this point, again, it's just simple foiling. We're just going to multiply this whole thing out. So x squared times x squared minus 7x squared minus 6x cubed plus 42x plus 9x squared minus 63. Combine like terms, write our exponents in order from biggest to smallest, and this is a function, so I'm going to say f of x equals. So this is going to be x to the 4th minus 6x cubed plus 2x squared plus 42x minus 63. All right, very similar in the next one, except we're dealing with imaginary. So if 2 is a 0, again, x minus 2 is a factor of this polynomial. If 3i is a 0, so is negative 3i. So one of my factors will be x minus 3i. The other factor will be x plus 3i. And again, you may notice this looks like a difference of squares. Well, when you multiply a difference of squares, again, let's go ahead and FOIL these out. I would have x squared minus 3ix plus 3ix minus 9i squared. Those middle terms are going to cancel out. All right, then that whole thing is multiplied by x minus 2. Now we have to remember some of our properties of imaginary numbers. So 9i squared, or just I squared, is a negative 1. So if it's minus 9i squared, that is the same thing as plus 9. Then from here, again, we're just going to FOIL it out. So x cubed minus 2x squared plus 9x minus 18. And that is what f of x is equal to. It's in standard form because my exponents go in order from biggest to smallest. All right, so what we're going to do now is we're going to look at a couple more complicated examples. So we're going to look at what happens when we have some of those more complex roots. So instead of just a square root, we're going to have like a number plus or minus a square root. So there's a couple different ways that you can work this out depending on what method makes the most sense for you. So one way that we can do this, if 5 is a 0, x minus 5 is a factor. If 2 minus root 3 is a root, so is 2 plus root 3. So we could set this up the same way as we want to. We could do x minus 2 minus root 3, and we could do x minus 2 plus root 3, and we can try and FOIL this whole thing out the same way we've been doing. The problem is I would not recommend FOILing this out in its current state, because it's going to get pretty messy with some of your square roots and what cancels when you have x's combined. So it will work. You will get the right answer, but it's a little bit messier. So if you're going to FOIL this out, what I would recommend is some creative grouping. And what I mean by that is I'm going to group those x minus 2's in their own little set of parentheses. And what this does is this creates a difference of squares. So in order to FOIL this out, I can do x minus 2 times x minus 2. I can do minus root 3 times root 3. And then those middle terms will cancel because it's a difference of squares. Then from here, I can actually square double square. And then simplify to make that just plus 1. So that is one method that we can use here. There's another method, though. I think it's harder to remember, but I think it's simpler to do. So we're still going to get, I'm actually going to leave that there so you can see that we get the same thing. So our goal is to get the factor that is going to give us these zeros. That factor is the x squared minus 4x plus 1. Another way we can do this is we can work backwards. So I know that those are my roots. So I know that x equals 2 plus or minus the square root of 3. So I'm going to work backwards to try and get that factor. So to work backwards, the first thing I'm going to do is I'm going to subtract 2. Then I want to get rid of the square root, because we usually don't have square roots within our factors. So to get rid of a square root, I'm going to square both sides. Well, x minus 2 squared, remember, that is x minus 2 times x minus 2. So that means I'm going to square, double, and square. And then when I square the square root, it doesn't matter if it's plus or minus. Negative times negative is positive. Positive times positive is still positive. So either way, I'm going to get 3. Set it all equal to 0, and I end up with the exact same thing that I had using the other method. So it's up to you. Whatever method makes the most sense is the best one to go with. I'm probably going to show more examples using this way because to me I think it's simpler, but it is a little bit harder to remember. It's not as intuitive probably as the other method is. All right, so now let's finish this up. We want to write it in standard form. So what's in red, okay, that is just the factor that gave us just the irrational roots. We still have that x minus 5. So to get my final answer here, I do need to FOIL this all out. So x cubed minus 4x squared plus x minus 5x squared plus 20x minus 5. Then from here, I can go ahead and combine like terms. So I end up with x cubed minus 9x squared plus 21x minus 5. All right, so again, whether it's an irrational root or an imaginary root, we can use the same methods we just talked about. So option 1, first of all, if 1 is a 0, x minus 1 is a factor. If negative 2 is a 0, x plus 2 is a factor. That part has not changed. If 3 plus I is a root, I can either do x minus 3 plus I and x minus 3 minus I and FOIL it all out. Whether I FOIL it the long way or I FOIL it as a difference of squares, either way will work. One thing I will caution you about, if you set it up this way, notice on both of these examples when we set this up, the minus always came after the x. That is not the sign that we changed. The sign that we changed was the sign that's in between the I and the 3. That's the sign that we change. So just keep that in mind if you're actually going to write it out this way. But again, I'm going to do it using that other method because I think it's just a little bit easier. So to get the factor that gives us the 0 of both 3 plus I and 3 minus I, I'm going to do x equals 3 plus or minus I. And I'm going to work backwards. So minus 3, square both sides. X minus 3 squared, we're going to square, double, square. And then whether it's a positive or negative I, either way, it's going to be an I squared. And if you remember back from last semester, I squared is negative 1. So set this equal to 0, and the factor that I get is x squared minus 6x plus 10. So that is what gives me the zeros of both 3 plus I and 3 minus I. If you don't believe me, if you want to go ahead and solve that with the quadratic formula or solve that with completing the square, you're going to get 3 plus I and 3 minus I. All right, so now to finish up this problem, let's go ahead and take the x minus 1 and the x plus 2 and FOIL those out. So that gives me x squared plus x minus 2. So now I've got two trinomials. I just got to multiply them out together. So I get x to the 4th minus 6x cubed plus 10x squared plus x cubed minus 6x squared plus 10x minus 2x squared plus 12x minus 20. Combine all your like terms. So I get x to the 4th minus 5x cubed plus 2x squared plus 22x minus 20. So it's a long polynomial. But again, the actual math here is nothing more than we've done back in our quadratics unit. Kind of the tricky part is actually remembering kind of that step and figuring out how to get this trinomial that gives us either the complex or the irrational zeros. All right, so let's just look at a couple different examples. I will tell you the bulk of the homework is going to focus on kind of those first couple that we just did. All right, so this one, we're going to find a polynomial of degree 4. It tells us the zeros. That is not 1.2, by the way. That is a comma right there. So it gives us the 4 zeros, but this time it doesn't tell us to use a leading coefficient of 1. So what we have to do is we have to solve for our leading coefficient. So what I do now, I know my zeros, which means I know the factors. So my factors are going to be, the factor that gives me 0 is just x. The factor that gives me negative 1 is x plus 1. The factor that gives me 2 is x minus 2. And the factor that gives me negative 3 is x plus 3. But this time, I need for f of 3 to equal 288. In order for that to happen, there has to be some sort of leading coefficient out here. So in order to solve for that leading coefficient, I'm going to do something very similar to what I did back in the quadratics unit. I'm going to plug in 288 for y, and I'm going to plug in 3 for all of my x's. And then I can solve for that value. So this is a times 3 times 4 times 1 times 6. So that's going to be 72 times a, divide by 72, and that should give me 4. Now that I know that leading coefficient, I just have to write it in the beginning, multiply it by the factors that I already have, and I have my polynomial. So that leading coefficient of 4, it doesn't affect your zeros. It does not change your zeros in any way. Those factors are still the same. I still have the same zeros, but the size of that number affects some of the other points on the graph, like the y-intercept or what the y value is that's associated with the x value of 1. And that one we didn't need to FOIL out because it did not tell us that we needed to write our answer in standard form. So we're keeping it easy and we're just leaving it in that intercept factored form. All right, so the last ones that we're going to look at are going to be pretty similar to some things you've seen before, applying transformations. All right, so the cubic parent function is horizontally compressed by a factor of 3/4 and reflected over the x-axis, followed by a shift up 7. So let's write our new function. So we're going to take the cubic parent function and compress it by a factor of 3/4. So remember, that means inside the parentheses, and the horizontal stuff is backwards. So that is my horizontal compression. Reflecting over the x is a negative outside the parentheses. And then shifting up 7 is just a plus 7. All right, looking at 4, a little bit harder. It's a different function, and then order here is going to play a factor. So to start, this is going to shift to the right 3. Well, if it shifts to the right 3, it's not going to be x minus 1. It's going to be x minus 1 minus 3. So it's x minus 4. All right, it is also going to be shifted down 4 from where it already is. Well, it's already at plus 3, so if it goes down 4, it's at minus 1. Then the last step is a vertical stretch by a factor of 5. Now, that means that I'm going to do 5 times f of x. That means 5 times the function that I already have. So I take the entire function and multiply it by 5, which is going to change that value to a minus 5. All right, then the last one, similar type process, a little messier in the algebra though, because we're not dealing with a cubic parent function transformation. We have a generic polynomial here. So the first step, it says that this function is shifted right 3 and down 4. Well, in function notation, right 3 is f of x minus 3. Down 4 is just f of x minus 4. So on my function, this means I'm going to replace my x's with x minus 3. Minus 4 just means I take that whole function and I subtract 4. So that's a little bit of an easier step. So now we actually have to go through and FOIL this whole thing out. So x minus 3 cubed is x minus 3 times x minus 3 times x minus 3. So let's go ahead and multiply the first two together. And then multiply by the x minus 3. And then simplify, and I end up with x cubed minus 9x squared plus 27x minus 27. All right, then I also have the rest of this function. So all of that was just the x minus 3 cubed. So we still got a little bit of ways to go here. All right, so then at this point, we'll go ahead and do x minus 3 squared. So it's plus squared, double, squared. And then plus 3 minus 4 is just minus 1. So let's finally combine those like terms. And I end up with x cubed minus 8x squared And then I have plus 21x minus 19. So after all that work in messy algebra, we're done with that first big step. Now the last step is actually really short, but keep in mind that was just the shift right 3 and down 4. The shift right 3 is really all of the algebra behind that, just because we had to cube it and square it and combine like terms. This is really just a big foiling question. The last step is a reflection over the y-axis. So remember, reflecting over the y is f of negative x. That means I replace all of my x's with negative x's. So that means my new function, we'll go ahead and call it g of x. I'm going to replace those x's with negative x's. And if I have a negative x cubed, that is now a just negative x cubed. But if I square a negative x, it doesn't change the sign. 21 times negative x is now minus, and that is my final new function. So again, this one's a little bit harder, just transformation-wise, because it's not a cubic parent function. But again, let's just be familiar with what those transformations do. All right, so that is it for today. We'll get some more practice on this before your test.